thanks WoodSolutions for the invitation to talk today. Personally, I'd also like to acknowledge the traditional owners of the land. I'm speaking today from the northern beaches of Sydney. It's a Gadigal country, so I'd like to pay our respects. And as Alistair said, the 3 guides have been released recently under FWPA guide. And I'm talking about the second one primarily today, which is Forest Plantations, Wood Products and Australia's Carbon Balance, which we did in collaboration, I think, STEP as well with Steve Mitchell. Just to start, so one of the things with carbon is that terminology can get quite confusing. So it's important to make sure everyone's on the same page. So if you talk about carbon, it's important to understand the difference between things like carbon sequestration and carbon storage, for instance. So carbon sequestration is the active process that the trees undertake of capturing carbon dioxide from the atmosphere, and that then gets stored in various components of the tree and the soil as well. So carbon storage is what happens after the sequestration has taken place. So that's when carbon is actually contained in a range of different products, for instance, paper, timber, or panel products, and then eventually wood in landfills. I'm sure everyone has heard about carbon offsets. I guess a classic example is when you fly and you're asked whether if you'd like to offset your emissions from your flight. That typically involves, the airline promising to plant a tree somewhere else. So basically, that's what it is. It's an action. It's designed to be an action intended to compensate for carbon emissions, and it can be under a variety of different options there as well. And the last one, another key definition there is around biogenic carbon. It's just a way of differentiating between carbon in live or living biomass systems as opposed to carbon in fossil fuel systems. Because carbon in plants and etc. That's part of the natural cycle that's happening now, whereas carbon from fossil fuels, is derived from geological timeframes. So it's just a way of differentiating those 2 types of carbon. Now, when we talk about forests in Australia, it's important to understand, what is the extent of the area that we're dealing with. And in Australia, under the latest estimates, the total forest area is in the vicinity of 134 million hectares. As you can tell from this map, a lot of these forests are concentrated on coastal areas of Australia, because obviously that's where it's higher rainfall, therefore more suitable areas for large areas of forest to grow. The vast majority of those forests are native forest areas, with the plantation estate in the vicinity of about 2 million hectares, but unfortunately that has been decreasing at least slightly over the last few years. And below here as well, we've got the net harvestable area, which refers to the proportion of the area within the public native forest estate, which is able to be, or where it can be accessed for purposes of wood production. That figure now has been reduced quite significantly since Victoria and Western Australia have decided to no longer harvest the native forest. So that area now is more around the 3 million hectare mark. Now, when we talk about carbon, it's important to understand what is the process by which trees actually absorb their carbon from the atmosphere. And that is through a process called photosynthesis, which I'm sure most of you would have heard about. And that's basically a way, it's a process where the CO2 in combination with water and the energy from the sun gets converted by the trees into the building blocks that make up the trees, which is basically the carbohydrates and another major element, which is the lignin. So in that process, those carbohydrates, the sugar molecules are produced, and in that process as well, oxygen is released back into the atmosphere. Now, in the guide, there are a range of different facts and figures around carbon in Australian forests, which can be quite helpful in understanding, how what is the current picture from an Australian forest perspective. So the first key element to mention is that forests in Australia store in the vicinity of 10.5 billion tons of carbon, and that does not include soil carbon. And to give you a sense of what that means, that's close to 80 times Australia's annual greenhouse gas emissions on an equivalent sort of basis. And if you do consider the amount of carbon stored in the forest soils as well, then that figure more than double. So that gives you some perspective around, the importance of managing that resource. The other thing to remember as well is that trees, the rate of carbon sequestration in trees really is related with age. So if you look at tall, dense eucalypt forests, which primarily used for the purposes of wood production in Australia, the growth rates decrease typically from anything around 6.4 tons of carbon per hectare per year. So that's, young trees are really hungry for carbon. They're sort of absorbing carbon at a very high rate. And that obviously, as the trees develop and they form their branches and their root systems, etc., that rate of sequestration decreases to about 0.7 tons of carbon per hectare per year. And once the carbon is sequestered by the trees, then it's divided into different elements within the tree. And basically, most of the biomass is in the woody fraction, the stem and branches and roots. And bark and leaves typically account for about 10 to 15% of the biomass in more mature trees. And if you think about carbon in the tree, so basically, if you were to remove all the water that exists in the tree, you would end up with 50% of the remaining mass as pure carbon. So that gives you a sense about how much carbon actually is contained in trees. The other key element to understand is what causes emissions in forests. So it's not just about sequestration of carbon, how that carbon may actually be emitted or lost. And in forest systems, that's primarily via two ways, via bushfires. So to give a sense of how relevant there is for the last major bushfires in Australia, 2019-2020 season, resulted in the emission of approximately 830 million tons of carbon dioxide equivalent, which is nearly 2 times Australian greenhouse gas emissions in one bushfire event. But obviously, naturally, every day, natural decay happens in forests, so that there are emissions that come from that as the parts of the tree that decay and that form, the coarse woody debris pool or the dead organic matter pool within the forest. Some of that carbon gradually is released back into the atmosphere as a result of decomposition and dynamics. And then if you're talking about production systems or production forest systems, you also have to account for any emissions associated with use of heavy machinery, like such as harvest gear and trucks for transporting the logs. But just back to the bushfires, this is a graph just showing you, just to give you a sense about how important bushfires can be from an emission generation perspective. And here it's basically for New South Wales only. And if you look at the profile for emissions from 2005 up to 2019, when those massive bushfires happened, you can see this huge spike. In 1 month in 2019, we had the equivalent of nearly 80 million tons of carbon dioxide equivalent being emitted into the atmosphere. So that's roughly around 20% of Australia's annual greenhouse gas emissions. So when you're looking at forest systems, you really have to look at all those elements. You have to look at the carbon sequestration and also carbon emissions, as I said, due to bushfire and decay. And then if you're looking at production systems, production forest systems, such as plantations or regrowth native forest mineral production, you do have the same elements, the same dynamics that take place in terms of carbon capture or carbon sequestration in the trees and carbon storage and coarse woody debris, and then emissions due to bushfire and decay, and the additional element of the emissions from harvesting timber processing. But also really important to consider the fate of carbon in timber. So how long the carbon remain products, what sort of alternative products those timber products will be displacing. So is there benefit from that? And then is there any energy opportunity there for generation from residues? Because at every step of the way in the supply chain, there are residues that are generated. It's important to consider the potential for that to be used in a climate-friendly way. So just the first element there, carbon in wood products and service. Basically, we quantify how much carbon is in the various types of wood products that we use in our daily life. And that's basically divided into different age classes. So short-lived products such as paper, medium-lived products, which basically if you think about say particle board or MDF panels for cupboards and things like that. And then long-lived products, as an example, wall and truss frames, with each one having different half-lives, which basically means that at any state or any given time, there will be a proportion of those products that will be leaving the pool, and then a proportion that will be coming into the pool from that production from that year. So that is the estimation of carbon in products and service is a net result of that dynamics of new products coming online and then products being getting out of service. And the end result of the calculation is that close to 100 million tons of carbon is estimated to be stored in wood products in service in Australia currently. But then when you reach the end of life, three options, or in Australia, three key options for that. So recycling or reuse, basically that means that the product will be returned back to the same category that it belonged from. So if there is, say, a paper product that was came out of it's a newspaper that was recycled, and then after the recycling has taken place, then it comes back to that same pool of products. So it basically, the net impact from a carbon perspective is positive because you're retaining the carbon in service and out of the atmosphere. The other option is around bioenergy, not so used in Australia from an end-of-life perspective for different types of products, but still relevant from a climate perspective. And I think the really important thing to understand is if you look at this simple diagram here, the opportunity here we're talking about is around construction and demolition waste, for instance. There's a lot of that material that actually reaches landfill at the moment, and there could be a potential alternative way of using it by producing biofuels. And if obviously, the production of biofuels will release carbon. If you're producing liquid biofuels and whatever, when you burn that will obviously produce carbon dioxide, which will be returned back into the atmosphere. But the important thing here is that if it comes from a sustainable system, those trees will be regrown and they'll be reabsorbing the carbon dioxide again. So in essence, it becomes almost like a carbon neutral system. And the difference here with coal or in any fossil fuels is that when the carbon dioxide is released, there is no equivalent tree to be absorbing the carbon dioxide. So it's a permanent emission or permanent damage to the climate. And that benefit is acknowledged by the IPCC, Intergovernmental Panel on Climate Change, which basically, on all the scenarios for limiting global warming, they rely heavily on bioenergy to achieve those targets. And then the other one is what happens to wood in landfills. Unfortunately, in Australia, most wood products still end up in landfills. Historically, large portions, so anything between 1.5 to 2 million tons each year, which is a very large number. So it's really important to understand what happens to that carbon, because if it's decayed. So basically in landfill systems, when organic materials decay, they release both carbon dioxide and methane in roughly equal proportions. The problem there is that methane is a much more powerful greenhouse gas than carbon dioxide. So if there is a high proportion of that carbon that gets decayed, there will be a high proportion of methane produced. And then therefore, that will have a very negative implication for the forest sector and potentially negating any of the carbon benefits from upstream. So it's really important to understand those what actually is happening to those products from a carbon science perspective. We've done a lot of work in the space. That's actually my topic of my PhD that I did a few years ago. And that was basically, looking at both products excavated from actual landfills and doing analysis to show how much carbon has been lost from those, and also doing experimental work in the lab. So I'm just going to show you a few pictures of some of the excavation work we've done in the past, just to show you that we actually have done it. And there was both been done in New South Wales and Queensland, a range of different landfill types. And just a few pictures of some of the products that we recovered, and after 20 years in landfill, cardboard and copy paper products, newspapers, books, different quality of books. But really the main point here is to show that this picture illustrates the concept, basically, where you see a highly durable timber here in the middle, ironbark, and then a few different types of radiata pine products along the side. And they were all 46 years in landfill. And there was no discernible difference in terms of decomposition in landfills. And that's just showing some examples of engineered wood products. That's MDF. Basically, the layers obviously peeling off because of the glue that's been leached out, but by and large, the biomass is still contained in the MDF section. So we did a lot of experimental work to corroborate, to try and sort of confirm the results from our excavation work. And basically, to cut a long story short, we published a number of different papers on this. The end result was that only a maximum 1.5% of the carbon in wood is actually potentially lost from Australian landfills. And that is because landfills become anaerobic very quickly. And under anaerobic, so no oxygen conditions, the mode of decomposition changes from fungal to bacteria. And bacteria are nowhere near as effective at degrading wood as fungi are. So that is what the fundamental difference is between decay in above ground conditions and decay in landfill conditions. So that basically results in landfills representing a growing reservoir of carbon in Australia. The latest estimates in the vicinity of 52 million tons of carbon currently stored in Australian landfills. And if you look at both the combined storage in wood products in service and in landfills, that is roughly equivalent to all of Australia's greenhouse gas emissions in 1 year. So it's really relevant. Now, we talked about carbon storage in products. The other opportunity or the other benefit is the product substitution, which is it's basically a virtual benefit. And the way that it's expressed is basically quantifying the benefits that would have typically over other materials. So basically renewable, it requires low amounts of energy comparatively for manufacture. You have the ability to use the residues to generate energy, and obviously it's physically stored carbon. So there is a metric that you can actually use to quantify the benefit, which is basically saying it quantifies how much carbon can be saved for every ton of carbon that is produced in different types of wood products. And typically in the literature, in the previous work that we have done, that benefit can range anything between 1 and 2 tons of carbon benefit. But maybe an easier way to understand that difference is by looking at a chart that we produced for a previous project, which looked at the relative carbon footprint of production for, say, native Australian hardwoods at the bottom line here, compared to alternative products. And the y-axis here represents the emissions associated with every ton, equivalent emissions associated with every ton of carbon in the timber that's produced. So it's basically a metric to say, the higher it is, the worse the is from a carbon footprint perspective. And if you just take one example here, if you look at Australian hardwood decking, if you compare the carbon footprint of that with that of things like treated pine decking, then there's not a huge amount of difference, which I guess you wouldn't expect to be much difference because they're both sustainable, renewable products. But then if you compare those two products with timber decking that comes potentially from unsustainable sources in Southeast Asia, so merbau potentially that may not be from great credible sources, then that has a very much higher carbon footprint. And that is because that the carbon footprint is driven by the loss of forests that would have incurred and the land clearing basically without the regeneration of the forest. And then that is driving that massive difference in terms of the carbon footprint. And if you look at electricity poles in the middle as well, that's comparing with concrete and steel poles, and roughly that difference is about 5 times greater for steel and concrete in terms of their emission footprint. And then you can combine all of that into an analysis that sort of compares the outcomes of managing forests for conservation alone versus a forest that's managed for multiple purposes, including production. And when you include all the elements that we talked about before in terms of carbon storage in products, substitution elements, etc., then production forests can actually become a climate benefit much sooner than the conservation forest can be. So it's obviously depends highly on the forest type, depending on market conditions and a number of different things. But it's important to acknowledge that if you're looking at the carbon balance of different forest systems, you really need to look at the whole life cycle, not just the forest boundary, not just the storage, but look at substitution elements as well. When you look at all of those, production forests can be quite beneficial from a climate perspective. And also, that it's represented in terms of pine, not just from a native forest perspective, but from plantation pine perspective as well. There's some work done for FWPA a couple of years ago where they looked at what is the implication of harvesting 1 hectare of plantation pine from a carbon perspective. And so they did 2 things. They compared, so they basically assessed how many new dwellings that 1 hectare of plantation pine could support. So that's anything between 5 to 13 new dwellings with a net greenhouse benefit of anything between 55 to almost 200 tons of carbon dioxide equivalent compared to steel framed houses. And similar benefits as well if you use that same timber for the purposes of mid-rise apartment building. and the greenhouse emissions are even quite a bit higher than for the equivalent with two framed houses in the previous example. So it just shows that it's the range of different benefits that you can get from different types of wood products that can be quantifiable, both from a native forestry system but also from a plantation system. And there's a lot of opportunity as well for greater use or smarter use of some of the biomass resources as well. So once you harvest your trees and you use a lot of that for saw logs and traditional forest products, there's a huge opportunity to use the residues in a smarter way. And from a climate perspective, there's huge gains to be had if we use some of that residues to displace hard to decarbonize products such as sustainable aviation fuel, for instance, or renewable diesel, and also very novel products coming online like bioplastics, wood-based chemicals. So, the trend is that fossil fuels will become more and more restricted, hopefully, and biomass is a logical replacement in a number of cases. And that's recognized as well by the IPCC in a number of different reports over the years, recognizing that sustainable forest management really can help with our fight towards reducing the impacts of climate change. And just in the issue of time, and just going quickly through this, but and in Australia, the main mechanism in which that benefit can be acknowledged is through the national carbon market. So the AQ scheme and the plantation forestry methodology, which basically rewards forest growers for a number of different activities, but primarily for growing new plantations in areas that have been cleared for a long period of time. So there's a mechanism to quantify the benefit, how much carbon is stored in the trees, and then once you harvest, how much carbon is stored in wood products. So it's all accounted for, and the method also accounts for emissions due to usage of fuel, fertilizer, fire disturbances, etc. So there's a lot of detail in that, but just wanted to mention that there is one mechanism at least for which that benefit can be recognized in Australia, and you can see many more details if you go to that link there. And this is my final slide, and that's also all contained in that guide that we talked about. And this slide really just shows a range of different opportunities, both current and potential, for the forest industry to contribute towards climate mitigation. So, there's many things that are happening now that are positive, but there are many other things that could be looked at, including, things like alternative ways of managing fuel load in forests, management of residues, how can we optimize that? And it goes on through the processing sector and then the final use and disposal as well. So for more details, please go to our guide, but I might just leave it there in the interest of time, and thanks everyone for listening.
Thank you very much, and good morning, everybody, and thanks, Fabiano, for that terrific presentation on the policy and the landscape side of the carbon story for wood products. I'm focusing today a bit more narrowly on the role of wood products in zero carbon buildings. Just to introduce myself and ThinkStep, we're a sustainability consultancy with presence in Australia, throughout Australia and New Zealand. Our team there. So I'm not the only author of this particular guide on the ThinkStep side of things. We've got a whole team of sustainability experts throughout Australia, with a wide range of clients in the building, construction, demolition, not demolition, the design sector, and our mission is to help businesses succeed sustainably. So I'll be talking about this middle guide here, the role of wood products in zero carbon buildings, which is available through the WoodSolutions website. The other two guides, I see there's a link there on the WoodSolutions website now. We co-authored with Fabiano, Carbon Primer and Glossary, and the third guide there. So I'm going to be focusing on this guide here. And the contents, obviously, the 20 minutes I have with you this morning, I'm not going to be able to cover it all, but these are the contents of the guide, from embodied carbon down to some case studies. I'll be following that order, if you like, that in the contents, and just picking out a couple of highlights from the guide itself. So I encourage you to go download the guide and go through it, and I'm happy to answer any questions that you might have through the email or phone I'll show at the end there. So embodied carbon and buildings, that's got a high priority in terms of environmental impact in the building and design sector. But it's just a few definitional a few definitions about embodied carbon, and this graphic you see here is from the reproduced from the World Green Building Council's report on upfront carbon that they released in 2019. So embodied carbon really is the greenhouse gas emissions, and they're expressed as the carbon dioxide equivalents. So as Fabiano mentioned, methane is one of the greenhouse gases that's particularly high warming factor. Carbon dioxide is the major one, of course, but you have a whole range of smaller greenhouse gases. So embodied carbon is those greenhouse gas emissions. They're not operational emissions, so they're not from burning gas to heat your home or from electricity to heat or cool your home. And it's the embodied carbon within the building's project life cycle boundary. Now, embodied carbon is the sum of three different types of embodied carbon. You've got upfront carbon, which the Green Building Council and Green Star talks about a lot. You've got the use stage, from replacement of building materials, etc. Use stage embodied carbon and end of life carbon emissions. If you're looking at the whole life cycle of the buildings, you should really encapsulate all those stages of your building and the emissions associated with each stage. Now, a lot of you might be familiar with this particular graphic. It is based on the standard EN 15804, but it's also embedded in a lot of other sustainable building standards these days. It goes through the different building life cycle stages, from the product stage to the construction stage, the use stage, and end of life stages of a building's construction. Now, this provides a bit more detail of the different life cycle modules, building life cycle modules. A1 to A3, what we call the production stage, construction stage, A4 to A5, and the use stage have module B and module C, end of life stages. So I'm just framing this now so you understand a bit more about what I'm going to be talking about later on. When we talk about embodied carbon, it's like I was saying, it's this upfront carbon from the production and construction stage. It's the emissions from using materials during for maintenance and repair and replacement, refurbishment during the building's life cycle. And it also encompasses reuse, recycling, deconstruction, waste disposal of the materials at the end of life of a building. It doesn't include these operational energy emissions. So that's the embodied carbon story. And upfront carbon, which is increasingly the focus, encapsulates the production stage and the emissions, carbon emissions, and the uptake of biogenic carbon in the production stage and the emissions from the construction stage. So that's what we're talking about when we talk about upfront embodied carbon. So the reason they look at these upfront embodied carbon issues is because these are the decisions we make today. They have direct impact on the emissions of your building. And they're often the highest impacts occur during the initial construction phase. Later modules, like the use stage, end of life stage, they're modeled based on estimates. Obviously, when you're building a building that could last 50 to 100 years, you've got to basically make a lot of assumptions about the impacts during the use stage and the end of life, how materials get disposed of or deconstructed. So this is something that we can be more certain about, which is why it's increasingly a focus for measurement and improvement. So just a bit about carbon storage in wood. This just represents graphically a bit more of what Fabiano was talking about. 50% of the dry weight of wood is carbon. That's just a physical fact. It's important to note that that's that dry weight. So after you allow for the moisture of the wood, 50% of the of the dry weight of wood is actually carbon. So that is stored in the wood as long as the building is standing, and even, as Fabiana was saying, even when the wood goes to landfill at the end of life. But it's all CO2 that was sequestered in the photosynthesis in the tree growing stage, and that's embedded in the wood for the life of the project. Now, life cycle assessment and environmental product declarations are how we account for carbon in timber and wood products. And I'm just going to touch a bit about on what EPDs are and what they represent. So EPD, Environmental Product Declaration, they're based on a product life cycle. So it's an ISO standards that it has to comply with. So it's a life cycle assessment of the whole product, including production, acquisition of resources, kiln drying, sawing, making the final product. Now, EPDs provide that clear, simple format for a wide audience, okay? And they provide trusted and credible information because they comply with those international standards. They're independently verified to meet those standards. So as a result, they're globally recognized. To be an EPD, it has to be publicly available. They're usually valid for 5 years. Okay, so some people equate it to a food label. I prefer the term, it's like a measure of environmental performance of a building or construction product is an EPD. They comply with what we call product category rules. Building and construction products comply with product category rules based on the European standard EN 15804. They include information like a declared unit. It'd be a cubic meter, say, for most timber products, or a square meter for a panel product. They include impact categories and methodology, data quality, and so again, emphasizing a PCR based on EN 15804 is really what you're looking at when you want to look at the data and ensure that it's credible and comparable. So we talk about carbon footprints, but there's EPDs include a lot of more information, not just about the carbon footprint of a product, but they include information about water, its contribution to water, air, and soil pollution in terms of acid rain, algal bloom, summer smog, energy use, or water consumption during the production stage. So when you're thinking EPDs, carbon is the measure that a lot of people are looking at now, but we use life cycle measures. Other environmental impacts can be as equally or more important in different contexts. So sure, look at carbon, but also consider what the trade-offs might be in terms of other environmental impacts. Yes, it also includes information about the energy use, for example, and how big a proportion of energy is from renewable or non-renewable sources, how much is from different minerals or fossil fuels, and what's its contribution to different types of hazardous or non-hazardous waste. Now, why do we go through all this jargon and buzzwords? And really, as a designer, you want to know what's the impact of your building by the use of different products. And that's what EPDs are designed to do. They're designed for designers and specifiers and people procuring materials to take that information, to put it in the context of their whole building, and then make a comparison between different design options or different material usage. And there is an overall standard for considering that, EN 15978, Sustainability of Construction Works. And you can just choose to measure the impact of carbon, embodied carbon or upfront carbon, but you might choose to use all those measures, all those environmental impacts that I just mentioned that are available in EPD. So that's what they're meant to do, to benchmark your projects and make better environmental decisions for your project, and there is a standard for that. But there also are other developing standards and Australian methods that I'll talk about that go into a bit more detail. Just to give you comfort, EPDs aren't going away. A lot of people don't like the numbers. They look a bit complicated. Well, you better get used to it. It's like a span table. It's just a fact of life if you're working in this space. And there's a huge growth in construction product EPDs around the world. At the moment, there's about 130,000 EPDs published through about 40 EPD programs. The EN 15804 compliant EPDs are just a subset of the EPDs that are available. And EPDs in Australasia are part of this small subset of EPDs that are developing around the world and published. So Australian timber industry was an early adopter of EPDs in Australia. I think we helped develop the second EPD published in Australia. We were just pipped to the post by the steel industry, but only by a couple of days. But now there are there's 7 industry average EPDs for the Australian timber industry: sawn softwood, hardwood, MDF, hardwood, particle board, glulam, sawn cypress. We're just updating a few of these at the moment, the hardwood, MDF, particle board, and plywood ones. We're getting those updated. As I said, they're valid for 5 years, so they've just come to the end of the life last year, a validity period last year. So we're getting those updated numbers. Now those numbers should improve given energy efficiency gains. So you can still use the data in them, but we're just saying the data is being updated at the moment. And increasingly, you're starting to get product-specific EPDs, which provide carbon footprint data and other environmental impacts for specific products, such as XLAM's cross-laminated timber panels, Timberlink's structural softwood, and products that are available in New Zealand and exported, such as Bodo Wood's heat-treated material, as well as LVL from Carter Holt Harvey in New Zealand. And we've got other clients in the works now that are producing these EPDs for their specific timber products. So what's in them? What's the carbon data say for the timber EPDs? Well, as I said, they don't cover the whole life cycle. They cover data for the production stage, A1 to A3, and the end of life stage. Now, I'm only going to talk about the production stage impacts here due to time limitations, but they do include data for both of those stages. That's the mandatory life cycle assessment stage EPDs have to report on. And here's an example from Australian softwood EPD, the kiln-dried addressed timber. You can see here that the biogenic carbon stored uptake from the wood in the tree when it was growing, minus 900 kilograms of CO2. And then you see the various fossil fuel emissions at the various stages of production. Okay, we've also got a biogenic greenhouse gas emissions other than CO2 that are emitted at a couple of stages here as well. Mainly that's from the combustion of some of the wood residues in the forest plantation. And so you add these numbers together and you get this carbon footprint. Okay, and I'll explain a bit more what those numbers are, but this is a grab from the Australian softwood EPD that gives you those numbers. Now, when understanding carbon and how to sort of deal with these numbers, it's important to know that we have fossil carbon emissions, we've got biogenic carbon emissions and storage, and you add those two together and you get the total carbon number for wood products. So this is a grab from our carbon guide, the WoodSolutions carbon guide, which includes the fossil carbon emissions for dressed softwood, kiln-dried and dressed hardwood, Australian glulam, Australian softwood and hardwood glulam, the biogenic emissions, the amount of carbon stored in the wood, and then the totals there. Okay. It's important to note that these biogenic carbon emissions aren't the CO2 emissions for, say, burning wood aren't counted if the wood is sustainably sourced. So it's very important that you still look at responsible sourcing of your wood products, whether that be FSC, Responsible Wood, or PFC certification, or another type of certification. It's very important that you source wood that's been responsibly and sustainably managed. Comparing data, we generally say, well, you've got to compare data that's, you've got to be fair when you compare data. You relate to the function that they fulfill. So use a functional unit, compare equivalent function within the building context, ensure the compliance with the EPDs comply with the same rules, same PCR for the both products. Also, you should be aware EP data has an error margin of plus or minus 10%. Just because something is slightly better doesn't mean it's better at all, because there is that plus or minus 10% within EPDs. And if you, just a note of caution, if you want to make public claims about your product compared to another competitor's product, you really should talk with an LCA EPD specialist so that you don't fall foul of any ACCC or accusations of greenwashing. Here's a graph from the brand's construct guide when we're comparing, say, the embodied carbon of different products. Here's 1 kilogram of beam and the numbers that with and without the stored carbon comparison there. You can obviously see that the glulam timber with the stored carbon is significantly lower impact, but that's not really a fair comparison when you're talking about a kilo of product. In terms of functional equivalence, it's fairer to sort of convert that to 1 beam of, say, equivalent structural performance, where using the data in EPD's brands has got these numbers comparing the impact of those 3 different products. So these are within the guide, by the way. Just moving on to the next item, green building and infrastructure certifications. How do you account for carbon is a developing field in Australia. We're working with the NABERS National Australian Built Environment Rating System to develop a tool to measure embodied carbon. EPDs are regarded as the preferred source of data. And just a special note for that, the NABERS methodology will include a greenhouse gas emissions number. So a person reporting under that scheme their embodied carbon emissions of their project will have to report on the, say, kilograms of CO2 equivalent per square metre. And they'll also, within that NABERS tool, there will be an opportunity to report on the stored biogenic carbon from products such as wood for the project, but they'll have to be reported separately rather than as a total. So we've worked with New Zealand Green Building Council, the Green Building Council in Australia, and NABERS to develop an embodied carbon calculator and methodology to make sure that the comparisons are robust and are consistent, so we can truly benchmark and then improve our the environmental impact of our buildings in terms of embodied carbon. EPDs as well can be used as evidence in Green Star and infrastructure sustainability rating systems. If there are any product manufacturers, please give us a call if you want to invest in an EPD. There's a little bit in the guide about the carbon reduction potential for embodied carbon. This graph from the UK Infrastructure Carbon Review really talks about scales the different options for building less, building clever, and building efficiency. I won't go into much detail here to say that using clever materials is where the using timber sort of fits into this curve. And I'll just finish off with a few case studies. This one is the Brisbane, King Street, Brisbane building. It's included in the guide. It is a 74% reduction in embodied carbon footprint over 60 years, which is if you include that sequestered carbon in the wood, a 38.7% reduction if they don't include that carbon stored in the wood. So very significant reductions in terms of embodied carbon for that project. the La Trobe University, Bundoora State student accommodation, a sort of similar order of magnitude of embodied carbon reduction compared to the reinforced concrete-based design, 7,500 tonnes of CO2 equivalent reduction. And lastly, the recently completed T3, not TT3, Collingwood. Now, they've done a comparative life cycle assessment in line with international standards listed there, but they've found a 34% reduction of embodied carbon by using these sustainably sourced wood products. So I'll finish there. Sorry, I've just gone a bit over time, but I'm happy to answer any questions. Thank you.
Thanks, gents. That was fantastic coverage of the topics. And as I mentioned to people, there's more detail in the guide. So please download those. We did get that question from one person about where can you get them. Just go to the woodsolutions.com.au website and you can access all three of them. But Fabiano, there was a couple of questions there that came in that you did answer online, but I thought they were excellent ones that we should relook at. Richard Howard asked about what needs to happen in Australia to improve the uptake of biomass energy conversion. Did you just want to chat about that, Fabiano?
Yeah, no, thanks, Alistair. So basically what I said to Richard, it really is, Australia is such a problem in terms of developing projects in this area because of geography. It's transport distances is the main issue, but also in terms of other things like having a more industry-friendly regulatory environment, having clear signals from government that they support for that opportunity, and also looking at at maximizing, optimizing supply chain systems as well. So there's a range of different things that need to be in place for that to happen. Yeah.
And actually, I really liked Brett's question. I actually hadn't contemplated that before, but as he mentions, as technology advances, I see the world's landfill sites as our future mines to re-extract resources. That's really interesting. With the reduction of harvestable timber available, making supply increasingly more difficult, is this something that's been looked at in the future to harvest landfill timber for reuse or biofuel? You might just touch on that, Fabiano. That's a great question.
Yeah, as I said, that it's actually a thing. It's happening in Europe, but more for high value products such as copper and high value metals and things like that. So the price, the value of that timber in landfill hasn't quite got to that level yet, but potentially in future it may be possible. But there's a bunch of different environmental considerations as well in terms of disturbing a system that's highly contained, and then some of the issues there from the environmental perspective. But in theory, it's definitely a possibility. Yeah.
Steve, a couple of questions here for you. So Howard just asked, are there generic EPDs for imported products to show the impact of importing and to encourage use of domestic alternatives?
Yeah, there are plenty of EPDs for timber, wood products, steel products, all sorts of products that we import into Australia are supplied into the Australian market. So a key thing to look out for is compliance with that EN 15804 standard to make sure that the data is comparable. Sure, we like to use domestic alternatives, but domestic timber, but there are plenty of good imported products there as well with pretty low embodied carbon profiles as well.
Yeah, and as Steve mentioned, most EPDs sort of cover that A1 to A3 sort of stages. The transport part, which is often the impact with imported products, is under that A4 category, which some EPDs actually do give some advice around, not all, but that does need to obviously be included when you're comparing a local or an imported product. Just I guess reminding people of timber imports, if they've come out in containers from a ship from Europe, reality is that the amount of emissions that have actually been, occurring in the shipping of that timber is very low, because really ships are reasonably efficient, and it's just sort of one container amongst thousands on them. So, but it is important to include that A4 value in it as well. Steve, yeah. Great question here from Toby Hodson, who does a lot of timber design. Question to Stephen: clients of building designers are not commonly advised of the carbon arising from end of life scenarios, focusing on upfront carbon, as you say, because that aligns with organisational targets and certification methods. Depending on end-of-life scenarios, there can be a wide range of values, and our clients typically feel the outcomes cannot be controlled by them or credited to them. since end of life for timber is significant, how would you recommend we communicate the overall carbon benefits to clients?
Yeah, it's a really good question. That's why our EPDs include the impacts from end of life. Okay, and we incorporate in the Australasian EPDs, we incorporate Fabiano and his colleagues' work showing that there is very little impact from landfilling wood at the end of life. Okay, so we incorporate that scenario in the data in the EPDs. Okay, but when you're talking about an end of life, some of the newer products such as CLT panels and the large glulam members, they're highly reusable. Now the data isn't there to support that in a peer-reviewed document because these products are very new in the Australian context. However, it is very likely that these large dimension timbers are going to stay expensive and be highly reusable at the end of life. So I'd be arguing with my clients that if you're using these panels and large members in your building, the reuse is going to take care of themselves. They're going to find their way on the back of a tradies ute or into a truck and get reused in another application, which is what commonly happens with highly valuable hardwoods in Australia. So you can get distracted by some technical details, but look at the bigger picture. Reuse, salvage of materials at the end of life is a very likely scenario. And then stick with the methodologies that, say, neighbours are developing as well. I think that's been highly consulted. There's been a lot of consultation around that.
Okay, thanks for that. Look, we're just running out of time now, so some terrific questions there. So thank you once again, Stephen Fabiano. Some fantastic information passed along. I just remind all those online that these webinars are recorded, so if you want to go back and relook at it or encourage your friends, just go to that section of the WoodSolutions website. So our next webinar will be in February, the 6th of February. So that'll be back to the first Tuesday of each month. So we encourage you to log in for that one. It's going to be a case study on the new St Luke's building down in Launceston with Dane Davis from BG&E. So I think that'll be of really terrific interest. So I want to thank everyone for joining us again today for our first webinar of 2024. We've got plenty coming, so we look forward to seeing you each month at the webinars or at our events in the States. Thanks once again, Stephen Fabiano, and thanks for everyone for attending today. Keep well. Bye.